In this video, I'm going to show you how to model with arithmetic series. Here's our first question. A car manufacturing plant can make 100 cars per month. The plant is expanding and is increasing its production ability by 5 cars each month, starting after the first month of the next year. How many cars will the manufacturing plant produce next year? Okay, so why don't we define an arithmetic sequence with AN. AN can be the number of cars produced in the nth month. Alright, so to find how many cars will the manufacturing plant produce next year, we need to sum up the number of cars produced in the first, second, third, all the way to the 12th month, because 12 months in a year. So we want to sum up A1 plus A2 plus A3 plus so on all the way up to A12. So why don't we recall that formula for the sum of the first n terms of an arithmetic sequence? Remember, the formula goes like this. N over 2 times 2A1 plus n minus 1 times the common difference. Capital N is, of course, the number of terms that we're summing up, so capital N is just 12. Then A1 is the first term of the sequence, and that's given in the problem statement. It says that the plant can make 100 cars per month. That's the starting amount. It's only after the first month that the number of cars per month starts increasing. So we're starting with A1 equals 100. And then D, the common difference, is what we're adding every time. So the production ability is increasing by 5 cars per month. It's increasing by 5 cars per month. So that means the common difference is 5, because that's what we're adding to every term in the series. So let's go ahead and substitute all this information in. 12 over 2 times the quantity 2A1, so 2 times 100, then plus n minus 1, n is again 12, so 12 minus 1, times the common difference, which is 5. Why don't we go ahead and simplify this a little bit before computing? So 12 over 2 is 6, 2 times 100, 200, then plus 12 minus 1 is 11, so 11 times 5. Punch that into the calculator, and the result is 1,530. So there we go. That's how many cars the manufacturing plant will produce next year. 1,530 cars. Here's the next question. A small concert is being set up, and there are 100 chairs for the audience. If each row is to contain 3 more chairs than the previous row, and there are to be 5 rows, then how many chairs should the first row contain? Alright, so let's go ahead and define our sequence again. We'll let AN be the number of chairs in the nth row. Now, since there are 100 chairs for 5 rows, we know that 100 has to be equal to the total sum of all those chairs in all those rows. So 100 equals A1 plus A2 plus A3 plus A4 plus A5. So again, we can simplify the situation a bit by writing the right-hand side, the sum here, using the sum formula for the first n terms of an arithmetic sequence. So 100 is equal to n over 2 times the quantity 2A1 plus n minus 1 times the common difference. And now again, we just have to go ahead and fill in some information here. So first of all, n, what is n? N is the number of terms we're adding up, so that's all the way to A5, so n is 5. Then how about A1? What is A1? Well, that's the first term. Are we told the first term? No, actually that's what we want to find. We want to find how many chairs should the first row contain. So A1 is going to stay as A1. It'll be a variable in this expression that we'll solve for. But before we solve for it, we also need to figure out what D is so we can plug that in. The problem says that each row is to contain 3 more chairs than the previous row, So each term is 3 more than the previous term, which means the common difference, d, equals 3. Alright, so let's go ahead and write this again, filling in all the information. 100 is equal to n over 2, so 5 over 2 times the quantity 2a1. Remember, a1 just stays because that's what we're solving for. Then plus n minus 1, so 5 minus 1 times the common difference, which is 3. And now we can just go ahead and solve for a1. Alright, so let's solve for this. First of all, there's a fraction, so why don't we get rid of that fraction? Why don't we multiply both sides by 2? So we'll just get 200 is equal to 5 times this quantity. And why don't we go ahead and simplify inside of this quantity as well? So we'll have 2a1, and then plus 5 minus 1 is 4, and then 4 times 3 is 12. So plus 12. And keep on simplifying. We can divide both sides by 5, and 200 divided by 5 is just 40. So 40 equals 2a1 plus 12. Now just subtract 12, get 28 here. 28 equals 2a1, and divide by 2 to get 14 equals a1. So there we have it. 14 is a1. That means that the first row should contain 14 chairs. Here's another problem. As a mountain goat is climbing a steep cliff, it knocks a rock off the edge. The rock falls 16 feet down the cliff in the first second, an additional 48 feet in the next second, and then another 80 feet in the third second. If the cliff is 500 feet high, then in which second will the rock hit the bottom? Alright, first let's go ahead and collect the information here. So we'll let an be the distance the rock falls in the nth second. So a1 is 16, and then a2 in the second and falls an additional 48 feet. So a2 equals 48. And then in the third second, it falls another 80 feet. So a3 equals 80. And let's just notice that this is an arithmetic sequence. 16 plus 32 is 48, and 48 plus 32 is 80. Okay, so we've got a pretty good idea of what's going on here. We've got our sequence, and what do we want to figure out? Well, we want to figure out if the cliff is 500 feet high, then in which second will the rock hit the bottom? Alright, so in other words, we want to find when the total distance fallen is equal to 500. And the total distance fallen is just the sum of the distances fallen in each second. a1 plus a2 plus a3 plus so on all the way up to an. And we don't know what n is yet. That's what we're trying to find. N will represent the second that the rock will hit the bottom. Alright, so how can we solve for n here? Well, one option is to, like we've been doing previously, just take this sum and use the sum formula to express it in a more simple manner. So let's do that. So the sum turns into n over 2 times 2a1 plus n minus 1 times the common difference. N, of course, is what we're looking for. That's the second that the rock will hit the bottom. But we know a1. a1 is just 16. And we know the common difference. The common difference is just 32. So we'll go ahead and plug in that information. We'll have n over 2 times the quantity 2 times a1, so 2 times 16, then plus n minus 1, and we don't know, that's what we're solving for, times the common difference, which is 32. And that's equal to 500. Alright, so let's go ahead and solve this equation. Let's bring it over here, because we'll have to do a little bit of work to solve it. So first of all, we've got a fraction here, n over 2, and let's get rid of that fraction. So let's go ahead and multiply both sides by 2, get rid of the fraction, get just n on this side, n times this quantity inside the parentheses. We'll fill that in a moment. But then that's going to be equal to 500 times 2, which is 1,000. And now inside of the parentheses, we've got 2 times 16, which is 32, then plus n minus 1 times 32. So distribute 32n, so plus 32n, and then minus 32. So 32 and minus 32 will cancel out, and so we multiply the n, we just get 32 n squared is equal to 1,000. So that means dividing both sides by 32, we have that n squared is equal to 1,000 over 32, which can be simplified a bit. 1,000 and 32 both divisible by 8. 1,000 divided by 8 is 125. 32 divided by 8 is 4. Alright, so now let's bring this back up to a new row of work. If n squared is 125 over 4, we can go ahead and get n by itself, remove that square by square rooting both sides. So n equals the square root of 125 over 4. So punching that into our calculator, we figure out that n is approximately 5.59. So we have to make a choice. Is it the 5th second or the 6th second in which the rock hits the bottom? And the way to think about this is that for n between 0 and 1, that's the 1st second. For n between 1 and 2, that's the 2nd second. So continuing this all the way down to an interval which contains this 5.59, for n between 5 and 6, well, it always corresponds to the right number here. 1 first second, 2 second second, 6 sixth second. So this value of n lies in the 6th second. So there we go. It's the 6th second when the rock hits the bottom. Great, so now we know how to model real-world scenarios with arithmetic series. And in the future, we'll also learn how to model with geometric series.